Welcome to Earth Science. Last week, you learned about the different characteristics of planets and the characteristics of Earth that makes it the only planet that can support life. The different Earth subsystems were also discussed and their interconnections with one another. In this module, you are to understand the solid Earth materials. You're going to differentiate minerals from rocks, identify their characteristics and properties, and analyze how they are formed through systematic processes. We learned that our planet is composed of three layers: the core, the mantle, and the crust. We're going to focus on this week's topic mainly on the crust because the crust is where we can locate most of our minerals. We are familiar with the word mineral. We have used it in various contexts, but in earth science, mineral has its own definition. Geologists define minerals as any naturally occurring inorganic solid that possesses an orderly crystalline structure and a definite chemical composition. Every highlighted word conveys that every mineral should satisfy all these conditions. Let us one by one discuss its characteristics based on the given definition. General characteristics of minerals. Naturally occurring. A mineral should be made or created through natural processes. As is stated, artificially made are therefore considered not minerals. Next, we have inorganic. When we say inorganic, the chemical elements of such mineral are not mainly anchored to carbon as the backbone structure, or is not mainly composed of carbon. They may contain carbon, but it is not the main element in their composition. Unlike organic substances, the backbone of their chemical structure is carbon. Minerals are considered to be inorganic because they undergo inorganic processes like crystallization, sedimentation, lithification, weathering, and others. Next, a mineral should be solid. No more states of matter are considered to be a mineral except solid. That is why ice is a mineral and liquid water is not. Next characteristic is definite chemical composition. There is an exact chemical formula for each mineral. Accurate ratios of element and compound combination will yield a certain mineral. For example, calcite will always have a chemical formula of CaCO3. Alteration of such chemical formula will yield another substance. Same is true with fluorite. It always exhibits CaF2, as well as hematite that exhibits Fe2O3. Another example that we could have is halite, or the common salt, with a definite chemical composition of NaCl. As seen on the diagram, we can see how sodium ions are paired with chloride ions. The ratio is always 1:1, meaning one sodium ion is paired with one chloride ion only. They form such structural pattern because of particle charges and properties. Such formation leads us to the next characteristic, which is ordered internal structure. When we say ordered internal structure, we mean the organization of atoms, formation of geometric patterns, or crystal structures. We have different kinds of crystal structures or systems. You can see it in this diagram. Say, for example, we have halite again. We can see in this diagram that the particles of NaCl arrange themselves in cubic patterns. That is why, if we're going to analyze a rock salt, it is in the form of cubes. Those are the different characteristics of minerals. It must satisfy all these requirements in order for it to be considered as a mineral. This excludes man-made substances, organic substances, and substances without a fixed composition, which are all classified as mineraloids. Now, how do these minerals form? Mineral formation happen in two ways. First, we have from stuff dissolved in liquids, and second is from cooling of molten material. Minerals are formed when liquid solutions evaporate, leaving the contained materials or minerals. Another way is when hot water solution is being heated or influenced by heat of underground magma. The elements and compounds in the solution lives in the process and crystallizes, forming minerals. The second way is through cooling down of molten materials. The cooling down of molten materials form specific materials or minerals and exhibit different features depending on the location where the mineral had undergone cooling. If the lava ejected on the surface cooled down, the resulting product are minerals with small crystals embedded on its surface. The cooling process is fast due to release of heat, lesser environmental temperature, wind, rainwater, thickness of lava, and others. Hence, the appearance of the mineral evidently shows small crystals. Why? Because the short span of time of cooling process, crystals do not have enough time to grow, making them small. Contradictory to that, when there is enough time for crystals to grow because of slow cooling, larger crystals are seen in the mineral surface. This happens inside the planet, where magma is located. Because of pressure and temperature, longer time is needed for magma to cool down. As it undergoes this process, crystals grow. And once the magma completely cools down, it evidently shows large crystals on the mineral's surface. Cooling that happens on the surface is termed as extrusive cooling, while cooling happening inside the planet is termed as intrusive cooling. We can see on the pictures that crystals are recognizable in granite compared to rhyolite because of their difference in cooling rate and cooling down location. Granite was formed inside the earth while rhyolite was formed on the surface. Hence, we can say that crystal formation in mineral surfaces is influenced by cooling rates, exposure to environmental conditions, and location. Now we proceed with the properties of minerals. These properties help us identify the mineral. There are 7 main properties and 6 other properties of minerals. Number 1, crystal form and habit. Based on definition, this property is the external expression of the mineral's ordered internal structure. The patterns and shape of the particles is already observable, hence showing its crystal habit. Here are some examples of crystal habits. We have cube, octahedra, blades, hexagonal prisms, dodecahedra, compound forms, rhombohedra, and tetragonal prisms. For easier understanding, we can have another example, our halite, which exhibits a cube crystal habit. In simple terms, when we say crystal form, it is the geometric shape of minerals caused by the arrangement of atoms in three-dimensional symmetry inside the mineral, while crystal habit is the external shape of the mineral. Next is number 2, luster. It is the ability of minerals to reflect light. Metallic minerals shine like metals while non-metallic do not. Here are some examples. By just merely looking at these pictures, we can easily identify the metallic from non-metallic ones. Number 3 is color. It is the most noticeable feature, yet unreliable, because the mineral's color seen by our naked eye may not be its true color. There may be impurities, alteration of color, or some may be colorless, thus difficult for mineral identification. The way to identify a mineral's color is through the next property, which is number 4, okay? Streak. This is the color of minerals in powdered form, which is more reliable color indicator. It can be done by rubbing the mineral on an unglazed porcelain called streak plate. You can also use an old tile or the sidewalk as alternative streak plate. Number 5, we have hardness, another useful property for mineral identification. We can determine the hardness of the mineral by letting it be scratched by a known mineral belonging to the standard hardness scale, the Mohs scale. Here is the Mohs hardness scale, starting from talc being the softest and diamond being the hardest. Next up is number 6, cleavage and fracture. For simpler definitions, cleavage is the breaking of minerals along weak planes in their structure. Breaking of minerals evenly, that is cleavage. While fracture is the chipping off of mineral in an uneven or irregular manner. Here is an example. Last property is specific gravity. Every mineral has their own specific gravity when plunged into a volume of water. Now let's proceed with the other properties of minerals. We can use these properties in order to identify some minerals. So we have taste, smell, elasticity, malleability, double refraction, and reaction to chemical acids, or chemical reaction to hydrochloric acids. Here is a picture of how double refraction is being exemplified. Now let's proceed with the next topic, which is all about rocks. Rocks are made from minerals, meaning to say minerals encapsulates rocks, and rocks is under the umbrella of minerals. We are familiar with the 3 types of rocks: the igneous, sedimentary, and metamorphic rocks. Given the information, we just need to emphasize on the main idea of each type. So we have these types of rocks. First one is igneous rocks, formed by fire. This rock is formed by cooling of lava or magma. We have examples of these kinds of rocks. They may also be crystalline, which was formed from cooled magma or lava, or pyroclastic, which was formed from accumulated and compacted volcanic debris. Igneous rocks may also be divided into two according to the location they were formed. So first division, intrusive igneous rocks are formed below the Earth's surface. This is also known as plutonism. Hence, we can also term these rocks as plutonic rocks. Igneous rocks formed on the surface through the process of volcanism is termed as extrusive or volcanic rocks. Next type is sedimentary rocks. These are products of compaction and cementation. The small sediments are being lithified with the help of running water, wind, ice, or living things. This is further classified into clastic and non-clastic sedimentary rocks. As the name suggests, clasts are mineral fragments, meaning clastic sedimentary rocks are those formed by accumulation and compaction of such fragments. On the other hand, non-clastic sedimentary rocks are those that were created through organic or biological activities. The last type of rock is the metamorphic rocks. These are products of metamorphism. The factors that affect to the production of these kind of rocks are the following. We have heat, pressure, and chemical processes. So we have examples here of metamorphic rocks. This type of rock is also divided into two. We have foliated and non-foliated metamorphic rocks. Foliated metamorphic rocks are those with significant layered or banded surface appearance, like this in the picture. While non-foliated rocks do not expose or do not exhibit such surface appearance, like this picture. Now, all these three types of rocks undergo continuous processes that are interrelated with one another. Such processes may yield a certain type of rock from its previous form. This is termed as the rock cycle. In here, we have given you statements pertaining to the flow of the rock cycle. We also have included different processes that involves the different kinds of rocks. It is more on self-understanding and independent learning. Given also here the diagram with arrows to help you in the flow of the processes involved in the rock cycle. That's all for today. I hope you learned something. Thank you for listening and always stay curious.